Alright, Algebra 2 class. With some suggestions to try and shorten videos and also maybe like make them more, make them more concentrated. I'm breaking the videos into two pieces. So this is going to be solving rational inequalities when one side is already 0. I'm going to do three examples here, and then I have another video with 2 examples when it's not 0. And you can see that on the notes I gave you. I gave, video 1, video 2. So I'm trying to make these, so I'm really going to try and talk less and make these as easy as possible. Your attendance today is fill out a Google form. Ask me any questions. I put the homework. I just got trouble with the homework yesterday. I put the answers to that up there. If you have questions on that or questions on this today, I'll try my best to answer them. It's just very hard, just not being in class, but we're doing the best we can. All right. So you get an inequality. X plus 1 over x minus 5 is less than 0. Okay, they're always going to be all fractions. Of course, those are rational expressions. I know you guys are probably over them. We are on our last section with rational expressions for a little while. Then we'll move back to actually hopefully some easier stuff, some more graphing stuff like that. But anyway. All right, so we get this problem here. We're asked to solve this inequality. All right, first thing you want to do is get one side 0. In this case, all these are going to already have one side 0. We're going to talk about the other 2 examples in the next video. So one side's already 0. Okay, well these are the simplest ones. Okay, what do we do next? Then what you would do is you actually factor out the top and bottom. In this case, you don't have to factor out anything. These are already factored out for you. All right, third thing you want to do is figure out where the numerator and the denominator equal 0. Okay, so what we're going to do is, I'm going to write like numerator, if I could spell. Yeah, I got it right. Numerator and denominator. All right, and then I'm going to figure out where do they equal 0. Okay, well this one, the numerator is going to equal 0, so where's x? The numerator is the top, right? That's going to equal 0, x equals -1. The denominator is going to equal 0, and x equals 5. All right? So I figured that out. Okay, now I'm going to draw a number line. All right? So I have, let's see, here's -2, -1, 0, 1, 2, 3, 4, 5, 6. All right, so I'm looking at -1, okay, this region, and 5. I'm not graphing, I'm just looking at these. So I have 3 regions I need to look at to see what my inequality solved is going to look like. I need to look at this region here in the middle, and this region on the other side of -1. I have 3 regions. So what I'm going to do is I'm going to plug in one number from each region and see, does the number come out less than 0 or greater than 0? All right, so let's try this region, right? So what I'm going to do is I'm going to plug in, so first I'm going to plug in from this region. I'm going to plug in -2. I'm going to see this -2, if I plug in -2 for x, does it make it less than 0 or greater than 0? All right, so I plug in -2, right? So I'm going to do -2 plus 1 is going to be -1 over -2 minus 5 is -7. So if you do that, right, that's going to be +1/7. This is going to be positive. This is going to work. So this region works. Okay, so less than -1 is going to work. All right. All right. So let's try. Oh, so this is greater than 0. So we're looking for something less than 0. My fault. So this doesn't work, right? Because -1 over -7 is +1/7. That is actually going to be greater than 0. So that doesn't work. We need to find something that's less than 0. All right. So let's go on this side. Let's try plugging in 6. So we get 7. 6 plus 1 is 7. 6 minus 5 is 1. That's also going to be greater than 0. So that interval doesn't work. So anything greater than 5 is going to be greater than 0. That's not going to work. Anything less than -1 is not going to work. Well, let's hope the middle works, and then we have our solution, hopefully. All right, so let's try 1. Let's plug 1 in. Okay, so we get 2 over 1 plus 1 is 2. Then I did 1 minus 5 is -4. 2 over -4 is going to be less than 0, right? That's going to be, so this one works. Okay, so what I'm doing is, again, so not be confusing, I'm trying to make it quick in less time. I'm just plugging in a number from each region, okay? So I plugged in -2 here. So I did -2 plus 1, -2 minus 5. You get -1 over -7. +1/7 is greater than 0, so that doesn't work. It needs to be less than 0. Then I plugged in a number from this region, okay? I plugged in 6. So I did, sorry about that, 7 divided by 1. So I did 6 plus 1 is 7, 6 minus 5 is 1. So number 1 is a positive number, it's going to be greater than 0. It doesn't work, it needs to be less than 0. Then here I plugged in 1, So I did 1 plus 1 is 2, 1 minus 5 is negative 4. That's a negative number, it's going to be less than 0, it works. Okay, so once you do that, so what's going to happen is, the only numbers that are going to work for this inequality are the numbers that are in between negative 1, that's here, and 5 here. Alright, so what I'm going to do is, I'm going to set up my answer, it's going to look like, so it's going to be x is going to be less than 5, not equal to 5, because 5 is going to make the function undefined, and everything greater than or equal to negative 1. So x is going to be between negative 1 and 5, but not equal to 5, because 5 is going to make the equation, we can't plug in 5, we can't divide by 0. So it's going to be everything greater than or equal to 1 and less than 5, but not equal to 5. And again, how I figured that out was, it's not going to be less than negative 1, because everything less than negative 1 is going to give me a positive answer, not going to be less than 0. Here, everything past 6 is going to give me a positive answer that's not less than 0. But everything in between negative 5, 5 and negative 1, is going to give me a negative answer. Besides, again, I can't plug in 5, because that would give me an undefined answer. This is my answer here. X is, so solved, x is going to be everything. So I can plug in any number between negative 1 and 5, and that's going to give me a negative number and going to make this inequality true. So we're looking for all the values that are going to make this inequality true. In this case, every number between negative 1 and 5, excluding 5, because 5 is going to make the equation undefined. Okay? Alright, so let's try a second one. Alright, again, these are all going to have that 0 somewhere in there. Alright, so hopefully that made sense. If not, we're still going to do a few more. And you're going to do more in the next video as well. So you got like 5 examples to look at. Okay, so let's say, look at the second one, you get x squared plus 4x plus 3 over, so I'm not trying to stay out in front of the camera, but I'm going to write, over x minus 1 is greater than 0. Alright? So the first thing we have to do is get one side 0. Okay, that's done. All this is going to be done. So now we're going to have to factor out whatever we can. So we're going to factor out the top here. That's going to become x plus 3, x plus 1 over x minus 1 is greater than 0. We're not simplifying again. We're just factoring everything out. Okay, so once you factor everything out, now we're going to figure out where is the numerator and the denominator 0. So let's write that out. So the numerator, I'm just going to call it NUM, the denominator. Alright, so the numerator is going to equal 0 when x plus 3 equals 0, or x plus 1 equals 0. So we're either where x plus 3 is equal to 0, or x plus 1 is equal to 0. So the numerator is going to equal 0 at negative 3 and negative 1. The denominator is going to equal 0 at 1. Okay, so we're going to have more regions here. So we're going to put like a dotted line at each of these regions, okay? So we're going to redraw my number line, right, to solve this. So we're going to have, what's it? So I got, what, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, that's fine. Alright, so we got 3 places. So I'm going to draw a dotted line at negative 3, that's one of the values I got. I got another value at negative 1. I got a value of 1. Alright, so in this case we have 1, 2, 3, 4 regions we got to check out, okay, to see like where are my values going to fall. And really this is, remember this is negative infinity if we keep going. This is negative infinity and a positive infinity, okay. You're going to need to know that because you might need to plug in infinity into some of these inequalities. So you should know that past whatever you're going past, that's negative infinity. If you kept going all the way this way is positive infinity, okay. Alright, so let's test a number from each of these regions. Okay, so let's test negative 4 on this side, right? So I'm going to plug negative 4 into here and see what I get. So I plug in negative 4, right? So I'm going to get, I plug in negative 4, I'm going to get 3 over negative 5. That's going to be less than 0. So if I plug in negative 4, I'm just plugging it in, I'm going to get 3 over negative 5. That's going to be less than 0. So it needs to be greater than 0. So that, this area past negative 3 to negative infinity doesn't work. Okay, so let's plug in, between negative 3 and negative 1, let's plug in negative 2. If we do that, I'm going to get positive 1/3, and positive 1/3 is greater than 0. Okay, so from negative 3 to negative 1, that works. All right, so now we're going to plug in 0. So now we have from negative 1 to 1, so we're going to plug in 0, basically is the only choice. So when I plug in 0, I get negative 3, that's going to be less than 0. So that one's not going to work. All right, and then we're going to plug in 2, and we get 15, which is greater than 0. Okay, so what does it look like? It looks like from negative 3 to negative 1, I got a good mark there, that's greater than 0. That makes this inequality true, as well as above 1. Okay, so how are we going to write this inequality? Okay, well, first off, I'm going to write this as x is going to be between negative 1 and negative 3, right? X can be greater than negative 3 and less than negative 1, in between negative 3 and negative 1. That's what that means. And, okay, there's going to be two parts to this. Remember, we saw the other inequality that worked. And x is going to be greater than 1 and less than positive infinity. Again, so x can be everything 1 and up. That's basically what this means. X is going to be greater than 1. That's going to be between positive infinity and 1. So from 1 all the way to positive infinity, but not, of course, not above infinity. And then x is also going to be between negative 1 and 3, because those are the two intervals that worked. So you're basically writing all the intervals that work. That's your answer. So if I plug in anything between negative 1 and negative 3, plus negative 1 and negative 3, they would work. As well as if I plug in anything but 1 and greater than 1, then that would work. So anything greater than 1 or anything between negative 1 and negative 3 will work. All right? So this is my answer here. All right. Okay. So let's do one more. We're going to do one more where it's 0. All right? And you can go to the next video. Then if you have trouble with just when it's not 0, okay, well then you have that video to go back to. All right. So one more of this example. Sorry, all right, so 3. All right, so let's say you get x squared minus 16 over x minus 1 squared is less than 0. All right, so first thing you're going to do, of course, is factor. So this is going to be what? X plus 4, x minus 4. You want to expand this out. It's going to be x minus 1, x minus 1. All right, so the numerator is going to equal 0 at 4 and negative 4. Hopefully we got that. The denominator is going to be just 1. So the numerator is going to equal 0 at 4 and negative 4. If I set these each equal to 0. The denominator is going to equal 0, x equals 1. It's the same thing. All right, so then I draw my number line. All right, so let's draw that out. All right, so I'm looking at, so let's do these values, right? So I have all the way to 4 and negative 4. So let's do negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. As long as you get one number before, one number below, that's all that matters. So I have negative 4, 1, which it can't equal 1, and 4. And it can't equal where the denominator equals 0 because it can't, because that's make it undefined. I'll never equal that. All right, so let's try one number over from negative 4. So we have 4 regions. So if I plug negative 5 in, I'm going to get 9 over 36, which is going to be greater than 0. So that's not going to work. That region does not work. All right. So the region, everything less than negative 4 to negative infinity is not going to work. So anything less than negative 4, nope, out of the question. It's got to be less than 0. Then if I plug in, okay, so I have between negative 4 and 1. So now I plug in, let's plug in 0. 0 is the easiest. So I'm going to get, if I do that, I get negative 4 over 1, or like negative 4, I should just write. So we get negative 4, and that is going to be less than 0. So from negative 4 to 1, that works. All right, so now I have from 1 to 4, this little region. So let's plug in 2. So if I plug in 2, I'm going to get negative 12 is less than 0. Okay. So I got these two. So I'm just figuring out, I'm just finding the answer, and then I'm saying is it less than 0 or greater than 0. If it's less than 0, I'm checking it as in like, okay, that region works. If I'm not, then I'm not checking it off. And then if I plug in 5, I'm going to get 9 over 16, which is going to be greater than 0. So that value doesn't work. So anything less than negative 4, anything greater than 4 doesn't work. But everything between 4 and negative 4 works. So what my answer here is going to be is, it's going to be negative 4 is, so we can't equal 1, so we have to like separate it out into two inequalities. So since 1 is not a part of my like solution set, because 1 is technically not a value, I would actually split this out into two inequalities with 1 being the head point. So I would go negative 4, so x is between, so x is greater than negative 4 and less than 1, and x is less than 4 and greater than 1. Since x can't be 1, so the reason I wrote this in two separate ones and not like negative 4 to 4, since x can't be equal to 1, okay guys, since it can't be equal to 1, I split out the two inequalities. I have to split it out into negative 4 to 1, and then 1's not a part of it, but then it's greater than 1 and less than 4. So if you have like a number in there that's where the denominator equals 0 in the middle of your interval, just make sure you write two separate inequalities to include like this to this, but not include that middle value. You can't. It's not just in there, because if you say x is between 4 and negative 4, that it means 1 is included, but 1 can't work. 1 makes this undefined. This equation. All right. So that is when these are solving rational inequalities when one side is 0. All right.